Today we're going to talk about the unit circle again and revisit that, but now talk about the x and y coordinates on the unit circle to go with our angle and radian measures. So before we do that, I want to review these special right triangles from geometry. The 45, 45, 90 triangle, it's not an accident that one of the angles on the unit circle is 45 degrees, but we know that these two lengths are congruent in a 45, 45, 90 triangle. And if we're referring to the unit circle, we know that the radius is 1. Well, the rule for 45, 45, 90 triangles, if I multiply the two legs by the square root of 2, I get 1. So if we go backwards and I give you the hypotenuse, that means our leg is going to be 1 divided by the square root of 2. Now we can't have that obviously because it's the square root of the denominator, so we multiply the top and bottom by the square root of 2 over 2, the square root of 2 over the square root of 2. The numerator becomes the square root of 2, and the denominator becomes square root of 2 times the square root of 2 is just 2. So that means each of these side lengths are the square root of 2 over 2. And if you wanted to, you could verify by using Pythagorean theorem to get this statement to be true. Then we have the 30, 60, 90 triangle. Well, in a 30, 60, 90 triangle, this is 30 degrees, this is 60 degrees. And again, our hypotenuse is 1. And the rule for the 30, 60, 90 triangle was that the side across from the 30-degree angle was 1/2 of the hypotenuse. Well, that makes this easy. 1/2 of 1 is just 1/2. And then the rule was take the smallest side here and multiply that by the square root of 3. Well, 1/2 times the square root of 3 is just the square root of 3 over 2. So these would be your side lengths of a 30, 60, 90 triangle. Well, now, if this 30, 60, 90 triangle is rotated so that way the 60-degree angle is down here and the 30-degree angle is up here, well, the hypotenuse is still 1. But now this side is the square root of 3 over 2, and this side is 1/2. So you'll notice a couple of things, and we probably should have written 45 degrees here, that the angle that is next to the x-axis here for all of them are angles on the unit circle. And what that tells us is that the coordinate, the x and y coordinates for each of these points are the same coordinate, the same values that we got when we used our special right triangle. And then this one was going to be that change. So just like how we reflected the angles and radians in different quadrants, we can reflect these values into the different quadrants, and we can call them as like families, where if you know it's a 30-degree family, you know that the x and y coordinates will be the square root of 3 over 2 for x and 1/2 for y, and that will then you just will change the sign based on what quadrant you are in. So for the 30-degree or the pi over 6 family, that's going to be the cosine value, which is x, and the sine value, which is the y coordinate. The x coordinate is going to be the square root of 3 over 2. That's what we had up here. The horizontal distance was the square root of 3 over 2. And then this is going to, the y value is going to be 1/2. So then your ordered pair will be the square root of 3 over 2, comma 1/2. I'm going to do the 61 next because it's the same thing as a 30 but flipped or switched. So now the x-coordinate will be 1/2, and the y-coordinate will be the square root of 3 over 2. So the ordered pair will be 1/2 comma square root of 3 over 2. And then the 45, 45, 90, that one, the x and y coordinate are exactly the same. The square root of 2 over 2, square root of 2 over 2. So then our ordered pair, that. And once we write these on the unit circle, we'll talk about some patterns that we see. One of the other things that we want to make sure we remember is that the tangent of an angle is the sine over cosine, that ratio reduced. But what that means is that once we start using these ordered pair here, well, those have fractions in it. So if we have a fraction within another fraction, that will just cause us to have to do some multiplying by the reciprocal. So another way of writing sine over tangent is sine over cosine, or y over x. All right, now on the next page is where we're going to actually fill out a unit circle. Now I'm going to go through and just copy down the angles that we already did earlier. I was going to do that real quick. 90's up here. So if you've forgotten why these angles are here, or how to get these measures, just go back to the previous video and we talk about it there. And 2 pi over 3, 3 pi over 4, 5 pi over 6, and then pi, and then I'm going to go and do the other ones down here. 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, all the way around is 2 pi, 7 pi over 4. Now you see that I kind of did these in different orders, just where, that's just where my brain was thinking at that point. I'm sorry, this is not 5, this is 5 pi over 3, and 11 pi over 6. So very rarely do I fill out the unit circle in order. I usually fill it out by those families. But I just wanted to get this done for us, and having to zoom in on my tablet does make things a little bit more difficult. All right, so I have all my angles and I have all my radians. Now I'm going to do the quadrantal angles first. So 0, 0. This coordinate up here, well, there again, here is my origin. I did not move left and right at all, but I went up 1. So 0, 1. Which means down here, I did not move left or right any, so that's 0, -1. Then over here is going to be -1, 0. So I'm going to start with the pi over 6 family. Now on the other page, we said pi over 6 or 30 degrees, that the x and y coordinates, the x coordinate was the square root of 3 over 2, and it's 1/2 as a y coordinate. And if you look at this triangle, it is longer this way than it is this way, than the y direction. And the way I think about it is 3 is bigger than 1. So that's how I know that the square root of 3 goes there, and then it goes always paired with 1/2. Now, this is another pi over 6 over here, so it's going to be the square root of 3 over 2, 1/2. But in this quadrant, we are now in quadrant number 2, where the x values are negative. So this will be negative square root of 3 over 2. We reflect that down here. We have another pi over 6. So again, we have the square root of 3 over 2, 1/2. But since we are in quadrant 3, both values, x and y, are negative in quadrant 3. If I just gave you a point in the third quadrant, the x value and y value are both negative. Then over here, we have the square root of 3 over 2. And then the y-coordinate is 1/2, but because we're in quadrant 4, the y-coordinate is now negative. Oops, I have too many square roots. So now I like to do the pi over 3 because I know for the pi over 3, it's going to be the pi over 6 just switched. So 1/2 square root of 3 over 2. Negative 1/2 square root of 3 over 2 because we are in quadrant number 2. Down here, both are negative, so negative 1/2, the negative square root of 3 over 2. And then over here, the y-coordinate is negative. So there we go. And then the last one is going to be the pi over 4. Now, some people do the pi over 4 first because the x and y coordinates are the same. And there's no problem with that. Okay, then over here, we are now in quadrant number 2 where the x coordinates are negative. And then down here, both coordinates are negative. And then in quadrant number 4, just the y-coordinate is negative. So now we have the whole unit circle filled out. All are positive here. The x and y values, x and y, are both positive in quadrant 1. In quadrant 2, y is positive and x is negative. In quadrant 3, they're both negative. And in quadrant 4, x is positive and y is negative. So now, some of the patterns that I want to point out, more than I've already pointed out some of the other patterns. If you look at your x values here, we go square root of 3, square root of 2, square root of 1, which is just 1. And then the y values go in the reverse order, 1, 2, 3. And then if we go over here, again, you can reflect, but again, it goes in reverse order. So my x values go 1, square root of 2, square root of 3, and the y values square root of 3, square root of 2, square root of 1, which is 1. So that's one of the ways that if you can just get your first quadrant down, that will allow you to figure out everything else a lot easier. But memorizing that first quadrant is absolutely essential. All right, so now down here, we're going to find the x and y values that correspond to the point on the unit circle. So 4 pi over 3, if we go back up and look, it's going to be negative 1/2, comma, negative square root of 3 over 2. And you're going to want to be able to do this without you looking at the unit circle. So B, 5 pi over 6, well, that's a pi over 6 family, and we know that pi over 6 will be square root of 3 over 2, comma, 1/2. But 5 pi over 6 is almost pi, which we know is in quadrant number 2, where x is negative. Oh, negative angles. Negative 2 pi over 3. So you could go 2 pi over 3 in this direction, or apply coterminal angles. If you apply coterminal angles, what you would get is you would add 2 pi, which is 6 pi over 3. And now this is one that is on our circle that we know much better, is the same as letter A. So then negative 1/2, comma, square root of 3 over 2. 11 pi over 6, that one is going to be the square root of 3 over 2, comma, negative 1/2. And then negative 5 pi over 4, again, you could add 2 pi either in your head or write it out. I tend to do that in my head. I say, okay, I know that if I add 8 pi over 4, 5 plus 8 is 3. I know that the coordinates of 3 pi over 4 or the negative square root of 2 over 2, comma, the square root of 2 over 2. So you did do some of this last year, and it should be coming back now. And the more we do it this year, the more that you'll be comfortable and memorize what we're doing. All right, now on this page, we're just going to re-emphasize that if we refer back to SOHCAHTOA, where, if this is our 30-degree angle right here, this is the opposite side, this is the hypotenuse, and this is the adjacent side, and combining that with what we did with the unit circle, this is 1/2, this is 1, and this is square root of 3 over 2. Well, the tangent, remember, tangent was the opposite over adjacent side. So in this case, it would be 1/2 over square root of 3 over 2. But remember, these are also x and y coordinates. So this is where the y over x comes from that we had on the previous page. So, combining that with sine and cosine values, the x value is going to be the cosine value, and the y value is going to be the sine value. So cosine goes with x, sine goes with y. So let's write down those ordered pair again on this page. The cosine and sine, or the xy coordinates for this pi over 6 family, that is going to be the square root of 3 over 2, comma, 1/2, then square root of 2 over 2, comma, square root of 2 over 2 for the pi over 4, and this one for pi over 3 is just flipped. Now the tangent is going to be the y value, the sine over cosine. So if we were to calculate that, so 1/2 divided by the square root of 3 over 2. Well, we know that instead of dividing, we can multiply by the reciprocal. So this is going to give us instead 1/2 times 2 over the square root of 3. Well, the 2's will cancel, but we can't have the square root of 3 in the denominator. So we multiply by the top and bottom by the square root of 3 over 3. So that gives us the square root of 3 over 3. Now, the one for 45 degrees is much easier because we are dividing the same thing. We're doing the square root of 2 over 2 divided by the square root of 2 over 2. They're the exact same thing, so that just equals 1. Now for the pi over 3, is going to be the square root of 3 over 2 divided by 1/2. And this is much easier because we won't have to rationalize the denominator. The 2's cancel, and we're just left with the square root of 3. So you can always figure out the tangent if you don't memorize it, but the easiest way I memorize it, is I look at the family. Pi over 6 has 2 3's in the tangent, and 3 plus 3 is 6. The pi over 3 family only has 1 3 in its tangent. So that's the way I memorize it, and that the pi over 4 is just 1. So down here, evaluate if possible the sine, cosine, and tangent. So the sine of theta, 7 pi over 6, well, the pi over 6 family has a sine value or a y value of 1/2. Cosine of theta is square root of 3 over 2. Now both of these angles, this angle is in quadrant 3, so both of these have to be negative. Now the tangent for pi over 6, remember I just said, is square root of 3 over 3 because 3 plus 3 is 6. Now, do we have to make this negative? In quadrant 3, tangent is positive because we are dividing sine over cosine. A negative divided by another negative gives us a positive value. So over here we have negative 5 pi over 4. I don't like dealing with negative angles on the unit circle, so I'm going to make this 3 pi over 4 by adding a full circle. Negative 5 plus 8 is 3. So now the sine of negative 5 pi over 4 is the same as the sine of 3 pi over 4, which is the square root of 2 over 2. Because this angle is in quadrant 2, where sine is positive. The cosine of negative 5 pi over 4 is the square root of 2 over 2, but it's going to be negative because we are in quadrant 2. And then lastly, the tangent of negative 3 pi over 4 is going to be 1, but because one of my values over here, one of my sine or cosine is negative, it's going to give me a negative tangent. So the more that you manipulate these unit circle values, the more patterns you will see. You'll probably see some that I'm not even aware of. If you do, please let me know. I'd like to learn them. But just make sure that you are studying your unit circle so that you are able to recall these values quickly. So thanks for watching. Make sure to like the video and subscribe.